Okay, now we're in part 6. So this is the total differentiation or total derivative. So hindi naman included na to sa differential equation, but I want you to know na for your understanding, no, what is total derivative. This is actually the previous, yung paano tayo nagde-derive, no, from the start. Yung isang dependent at isang independent. So, partial derivative, kanina, having two functions. But, sa total derivative or total differentiation, if c is equals again to the function of xy, like kanina sa part 5, which is a continuous function of two variables x and y that has a continuous partial derivatives of, okay, so ibig sabihin, yung x and y, you're going to get the partial derivative of c with respect sa first variable, let's say x, and partial derivative of c with respect doon sa partial derivative ng y. So, ito yung magiging parang formula niya. So, getting the total derivative of c, hindi na yan hindi na siya yung malanding d. With respect sa dt, so parang total derivative siya, is equals to the product of the partial derivative of c with respect sa x times the total derivative of x with respect sa dt. Plus, kasi two variable siya, two independent variable, so partial derivative ng c with respect sa partial derivative ng y, yung second independent variable, times, again, the total derivative of y with respect sa total derivative of t. So, if the case that you have two independent variable, so, i-imagine nyo naman kung magkakataon na tatlo yung magiging unknown variable mo. Let's say, let's see, equals, okay, halimbawa, a function of let's say, w, x, and y. Yan, tatlo naman. So, parang dadagdagan lang din natin, no, yung pinaka-formula, the total derivative of c with respect sa t. Naglolo ko lang yung pen. Equals by partial derivative ng c for the partial with respect sa partial derivative ng first variable times, okay, yung total derivative ng w with respect sa total derivative. Okay, so, susundan nyo lang yung pattern na yan. Partial derivative ng c with respect sa x naman times its total derivative. Okay, and last, partial derivative still ng c with respect sa y times the total derivative of y. So, ganun yung magiging pattern niya, no? So, hindi naman kailangan i-memorize. Okay, so ang tanong, paano nakuha itong pinaka-equation na yan? So, ito na tayo. Okay, to make it more or well explained, so if I have z, okay, gamitin lang natin yung two variables para hindi na ito. Okay, is equals to xy. So, dalawa yung independent variable ngayon natin. So, sabi dito, if I have two variables, if I'm going to get the derivative of c with total derivative of c directly, okay, Palabasin natin yung pinaka-equation niya. So, with respect sa t, it means product rule ang gagawin natin. Kasi with respect sa t, hindi naman with respect sa x, or hindi rin siya with respect sa y. So, product rule, x times the total derivative of y with respect sa t plus y times the total derivative of x with respect sa t. Okay, so nasusundan. Now, ano ang magiging value ngayon ni x at saka ni y? So that's the next question. So if I'm going to get, okay, rewriting again the equation, the partial derivative of the two independent variable, x and y. So, partial derivative of c, unahin natin muna kay x. Kaya, partial derivative of c with respect kay x. So, partial tayo ha. Magiging constant yung isa. So, magiging constant ngayon natin si y. Kaya, y times derivative of x is 1. So, yun ang mangyayari. And also, if I'm going to get, writing again, c equals xy, the partial derivative of c with respect sa y, so we have partial c over partial y is equals, okay, ang magiging constant naman ay si x. Kaya x, copy x, times the derivative of y, partially is 1. So, ito na yung magiging value ni x at saka ni y. So, substitute ngayon natin dito. Ayan. So, writing again the total derivative of c. Total derivative of c. So, we have x, where x is the partial derivative of c with respect sa y, times the total derivative of y with respect sa t, plus, okay, yung y naman is partial derivative of c with respect sa x times the total derivative of x with respect sa t. So, same answer din ang mangyayari. Okay, so, nagets na yung total derivative din natin is actually just the whole or yung kabuuan ng mga partial derivative. So, to make it more clear, we're going to have an example. So, sagot lang natin isa ha. So, moving on the example. Oops, sorry. Okay, if c is equals to x squared, y, x is equals to t squared, and y is equals to 2t. Find the total derivative or dc over dt. So, if you still can recall that problem, actually chain rule yan. No, sa chain rule natin makukuha yan. Kasi nga, si c ay equals kay x squared y. Ang hinahanap naman is the derivative of c with respect sa t. So, walang t kay x, walang t kay y. No? Doon sa main equation, let's say this is equation 1. Pero, hindi pa pwede maging constant si x kasi si x ay equal kay t squared. Tapos, hindi rin pa pwede maging constant si y kasi nga si y ay equal kay 2t. Okay. Kung ganyan yung problem, syempre, mas madali if we're going to apply direct substitution. No, para isolve agad natin si dc over dt. So, paano mangyayari? Direct substitution mo natin. So, c equals okay, x squared. So, si x, palitan na agad natin ng t. So, t squared na naka-squared. Tapos, si y, palitan na natin agad diretso ng 2t. Okay, so simplify muna natin na mas maayos. So magiging t to the 4 times 2t or simply equals to, okay, 2t to the 5th. So that is your c. Tapos pwede na natin i-derive diretso. Getting the derivative of c with respect sa dt kasi yun yung hinahanap. So we have dc over dt is equals to, okay, power rule lang naman yan, no? Bring down 5 times 2, we have 10t to the 4th. So, ganyan kadali actually yan, no? Pero, pag in case na yung problem ay may mga square root na yan, so, syempre, mahirap i-evaluate yan ng nung substitution ng directly. Kaya, ina-apply natin yung chain rule. Kung saan medyo mahaba lang siya, pero madaling i-derive kasi pinaghiwalay-hiwalay na yun natin. Now, pwede ba natin gamitin dyan yung partial derivative para ma-solve natin yung total derivative? So, yun yung ina-explain natin before. So, recalling again the formula, di ba? We have C. Okay, ano yung formula na yun? Okay, dc, over dt is equals to partial derivative ng c over partial derivative ng x. Ito yung formula kanina, no? Hindi ko na ulit i-derive, no? Kasi yun yung pinaka-formula na sabi ko madali namang i-memorize. Times its total derivative. Okay, plus, i-derive na natin kanina, partial derivative ng c with respect sa partial derivative ng y times the total derivative of y. Okay, ayan yung pinaka-formula ngayon natin. Kung ito yung pinaka-formula ngayon natin, we need to look for the components. Yan. Yung 4 na terms na yan. O function na yan. Okay, so isa-isahin ngayon natin. So, to solve for partial derivative ng c with respect sa x, okay, dito tayo pupunta sa main equation. C is equals to x squared y. Okay. Getting the derivative partially of c with respect kay x. So, partial c over partial x is equals, okay, constant si y ha. Kaya ang derivative ni x squared ay 2x times y. So, meron na tayong partial derivative ni c with respect sa x. Okay, so paano naman natin kukunin si dx over dt? So, si dx over dt, kukunin ngayon natin, of course, kay x is equals to t squared. So, we have x. Ito muna gawin natin. X is equals to t squared. So, getting the derivative, total tayo, with respect sa t. So, we have dx over dt is equals to, okay, derivative ng t squared is 2t. Okay na rin. So, meron tayong first and second function. Okay, now, for the second part, okay, partial derivative ng c with respect sa partial derivative ng y. So, kukunin ulit natin yan sa main equation or yung equation 1 na c is equals to x squared y. Okay, so same procedure. Getting the derivative of c partially, but this time with y. So, we have partial derivative of c with respect to y is equals to, okay, pag sinabi equals to, lang. Ay. Medyo nagulo, no? Intindihan pa naman. Okay? So, constant ngayon, si x. Kaya si x squared will remain x squared. Derivative ni y ay 1. So, medyo nagkalkulo na dito. We have this is x. Is t squared to. So, okay na tayo. Okay, so kung kukunin ko naman to si total derivative ni y with respect kay t, kukunin ko yan dito sa y is equals to 2t. Y is equals to 2t. So, getting the derivative, total naman to with respect na sa t. We have dy over dt is equals to 2. Okay, so, pagbabalikan ko na tong equation na to, so, meron na akong partial derivative ng c with respect sa x. Ito yun, si 2xy times dx over dt. Ito yun, dx over dt which is 2t. Okay, plus partial derivative ng c with respect sa y. Ito yun, which is x squared times dy over dt, yung kasasolve lang kanina, times 2. So, we have 2 times 2, 4xyt plus 2x squared. So, siya yung dc over dt. Yan yung sinusolve natin, no? Okay, so, equals. So, substitute the value of x. Ano yung value ni x? 2t squared. Oh, sorry. X is just t squared. So, we have t squared times y. Ano value ni y? 2t times t. Plus 2. Again, what is x? X is t squared na naka-squared pa sa labas. So, 4 times 2 is 8. T squared times t is t to the 4th. Plus 2, t squared raised to 2 is t to the 4th. So, similar terms, just add the numerical coefficient. You have 10 t to the 4th. So, this is now my total derivative ng c with respect sa t. Okay, which is the same answer. Okay, so mahaba lang yung sa chain rule, pero ang gusto ko lang ipaliwanag dito that you're going to have the same answer if you're going to apply partial derivative. So, kung sa application yan, for example, yung area ng rectangle, no? Area is equals to length times width times the height. So, 3 independent variable yun, no? Length, width, and height. So, yung ginagawa kasi natin dati doon, pag dinerive natin sa area, yung length, width, and height na 3 independent variable hanggat maaari ginagawa natin isa. Na puro length na lang lahat, or puro width, or puro height. Naghahanap tayo ng equations. So, pwede natin gawin, we can solve the derivative of area or total derivative of area by getting the partial derivative. No, unahin mo muna with respect kay length, tapos with respect kay width, tapos with respect kay height, tapos i-apply nyo yung total derivative, itong general formula. So, ganun din ang kalalabasan nun. Medyo mahaba lang siya, pero mas maikli. Okay, so that's it for our session sa partial derivative. So, yung process niya, hindi nagbago. Okay, para lang maintindihan ninyo. Kasi gagamitin natin yan sa differential equation. So, I hope you understand our topic and also have enjoyed. So, don't forget to subscribe, like, and hit the bell, no? Para sa tuwing may ipopost ako, na-update kayo na merong bago. Okay, so medyo mamimix lang yung video natin sa YouTube channel ko na may pang first year, may pang second year. So, lalagyan ko ng category yon kung differential equation or for differential calculus. Okay, so God bless us all and always be safe. Okay, bye-bye.